Which of the following represents the net ionic equation for the reaction between aluminium and dilute hydrochloric acid? Okay, so this is not an ionic reaction, so it's not B. Again, this is not an ionic reaction either, because the Cl is just a spectator ion, so it's not this one either. So it's between these two. So the net ionic equation won't be this one because there's no reduction half or reduction section. This is just the oxidation reaction, so it can't be this one. So it must be C. Okay. This is our net ionic equation. You can see the aluminium oxidizes and the hydrogen reduces to become hydrogen gas. Okay. So an observable change when a small piece of sodium is placed into a beaker of water is what? The density of the sodium becomes less. Okay, you can't observe that. You can't see that the density has gone down. You can see the volume has gone down as it's gotten smaller, but you can't see the density go down. The volume of the water decreases. The water probably doesn't decrease, so that's not true. Or if it does, it doesn't decrease by much. Sodium hydroxide is produced. Again, you can't see that. That's not observable. You can't say, oh, I see sodium hydroxide in my clear solution. You can't tell because you don't have molecular eyes. You can't see molecules changing, so it's not C. But you probably will see bubbles of gas forming, which are hydrogen gas. So you can see bubbles, and that's observable. You can see them, so that's D is our answer. Okay. These ones are probably true, but you can't actually see them happening. That's the difference between an observable change and a normal, just a regular change. Okay, so the difference is you can't see them happening. Okay. There are many reasons why there are more metals available for people to use now than there were 200 years ago. An incorrect reason is that, well, okay, the energy needed to decompose some metal ores was not available then. Okay, that's true. 200 years ago, we didn't have electricity, or we might have, but we didn't have, large enough quantities of electricity to get aluminium. So that's definitely a reason why we have less metals available. So that's not an answer. Catalysts, which make some chemical decomposition easier, were not available. Again, yes, that's also a reason why metals 200 years ago were not as abundant, because we didn't have all the catalysts that we needed. So that's not an answer either. The techniques needed to create new elements in nuclear reactors were not known. Again, that's not an answer because it is true. Some metals are now not available. Were not available 200 years ago because we didn't know anything about nuclear reactions. So that leaves us as A, there are more ores now than there were then. Okay, that's definitely incorrect. So it's our correct answer, but in terms of historical correctness, this is incorrect. So there were the same amount of ores back then as there are now. It's just that we can better utilize them for our own purposes because our technology is better. So A is the answer that we want here.